In this circuit, the switch has been at position A for a long time. At t equals 0, it switches to position B. We want to know the inductor current, I of t, at t equals 0 minus, just before the switch moves from A to B, t equals 0 plus, just after the switch has moved to position B, and as t goes to infinity. First, let's look at t equals 0 minus. The switch has been at position A for a long time, and the input is 4 amps. It's a constant. Under these circumstances, the current through the inductor will have become a constant. The voltage across the inductor will be 0, and the inductor will look like a short circuit. And the circuit becomes this. There's a 4 amp source, a 5 ohm resistor, another 5 ohm resistor, yet another 5 ohm resistor, and then a short circuit representing the inductor. And this is the inductor current at 0 minus. Since this is a short circuit, the voltage difference is 0 volts, and these two 5 ohm resistors here and here are in parallel. We know that there's 4 amps going into that parallel combination, and we want the current through this 5 ohm resistor. This is a perfect application for a current divider. So the current, I of 0 minus, is equal to the total current, 4 amps, times the other resistance, 5 ohms, over the sum of the two resistances, 5 ohms plus 5 ohms. That's 1/2 of 4 amps, or 2 amps. Now let's find I at t equals 0 plus. Inductors can't change their current instantaneously. That means that the current at t equals 0 plus has to be the same as the current at t equals 0 minus. Those two times are infinitesimally small apart. So using the result from the previous step, that becomes 2 amps. Finally, as t goes to infinity, the switch is at position B. It's been at position B for a long time. The applied energy is a voltage source. It's constant, 6 volts. So we have a constant input to the inductor. Under these circumstances, once again, it's the same conditions as over here, the inductor short circuits. The inductor looks like a short circuit. I have a 3 ohm resistor up here. I have a 6 ohm resistor here, a 2 ohm resistor here, and this 6 volt source. I want to find this current, I, at infinity. Since this is a short circuit, these two are in parallel. I can find this voltage from a voltage divider. So this equivalent resistance becomes 2 ohms, and this circuit looks like this. And V is equal to 1/2 of 6 volts, which is 3 volts. If this voltage V is 3 volts, then the current, I infinity, is 3 volts over 3 ohms, or 1 amp.